on how to SimShade your facade. My name is Helle Folbjerg Rasmussen, and I'm the head of performance and simulations at MicroShade. With me today, I have my colleague Asbjørn Riis Søndergaard, who will be moderating the Q&A session in the end. So if you have any questions, please use the chat function and I'll answer them in the Q&A session. In this webinar, you will get a tutorial introduction on how to SimShade your facade. I'll give you some insights in why and how SimShade uses climate-based calculations. And I'll give you some tips how to optimize your glazing and shading system. Please note that this webinar is being recorded and it will become available on our website afterwards. So let's jump into it. So SimShade is a free online calculation tool. It has been validated by Fraunhofer IC in Germany. And SimShade caters for the need for engineers, architects, contractors, glass manufacturers, and building owners. SimShade can be found on simshade.com. So if we go to the website of SimShade, you have two possibilities of getting into the calculator. Either you can use the big blue button here, calculate your shading solution, or you can simply choose SimShade in the top menu bar. So once we are in the calculator, we have different sections. So the first or the left section here is the input section. So these all needs to be filled out in order to do a calculation. And on the right-hand side, we have the results section. First, when doing a calculation, we need to decide if we are going to do a facade or roof calculation or we are going to do a building calculation. In this webinar, I will talk about the facade roof section. We will have a later webinar. I'll get back to that in the end, but here you can learn more about the building section. So we are on the facade section. If we look at the input section, first of all, the first section of the input is the glazing and shading build-up. We start by choosing how many layers of glass we have in our glazing. I'm sitting in a fairly old building, so I only have a 2-layer glazing, so I'll change it to 2-layer. Unfortunately, I do not have a MicroShade glazing. I have a low energy glazing, but I can choose between MicroShade, Solar Control, or low E. So I will pick the low E. And as you can see, as I choose different inputs up here, the glazing buildup that I have done here is changing. Besides the low energy glazing, I do have an external lamellar system. In here, I can choose between external, internal, or between shadings. And you can here see that the picture down here will change depending on what you're choosing. But I'm having an external lamella. For the external, I can choose between screen and lamella. So I'll choose the lamella. And then I need to choose how my shading is controlled. It can either be a static control, which means that the shading is permanently active. It can be manually controlled, or it can be dynamic or automatic control. So I choose dynamic. And then I can choose in details how my glass and shading is configured. In my case, I have a tilt of the lamella of 45 degrees. I will use a trigger value, so the threshold when the shading is activated of 150 watt per square meter of solar irradiation on the facade. And then I can alter the glazing buildup according to what I have. I have a 6mm front glass with a low energy coating. Then the gap is 16mm. Is not filled with argon anymore because it's a fairly old glazing, so I'm changing it to air. And then the last pane is also 6mm, and it's a laminated glass. So in order to have it laminated, I simply tick the box here. Then I can choose the glass area. This only has an effect on the economic results that I will show you later. I'll just leave it for 1 square meter here just for the example. Then we have an input section here, which is unusual in programs that can calculate glass and shading systems. In SimShade, you need to choose the location. I'm situated in Denmark, in Copenhagen. And the reason for us to have an input for the location and also window angle and orientation of the facade is because we actually use climate data in order to calculate the output values, and especially the effective G value, which is a calculation of the G value for every hour of the year, taking into account the position of the sun in the sky, and also weighting the G value for each hour with the intensity of the solar irradiation on the exact mounting direction of the glass. So in order to get that, I need these inputs down here. You can say if you have an east facade, the sun will rise in the morning, and then it will rise up and be at a maximum around the middle of the day, and then it will disappear from the east facade and will then move to the south facade. And by having these climate data, it means that I can actually, if I had an east facade, I could calculate for each hour when the sun was rising, what is the G value for each hour. My facade is towards southwest, so I type in 225 degrees in order to reflect that. And now I've basically given all the inputs. So now I press calculate. And then we can go and have a look at the results section. So first of all, we have some technical specifications. The first one is summer effective G value. So I just explained that the effective G value was this hourly calculation for the entire year and then weighted with the solar irradiation. When we talk about the summer effective G value, it's an average of the summer months of June, July, and August. So the effective G value for the summer is, the average for those 3 months. Then we have the light transmittance for the glass itself. And then we have a light transmittance for the glass, including the shading. So when the shading is activated, it has a light transmittance of 25%. And then we have the U value. It's important to note that the U value that we calculate in SimShade is related to the window angle. So let's say that I did not have a facade, but I instead had a roof, and it might be tilted, let's say that it has an angle of 25 degrees. Then what you will see is that then we will change it. And if we try to do a calculation, then you will see up here that now the U value is larger. And this is because the U value is changing with the window angle. I'm just going to change it back to the 90 because that's the facade that I have right now. We also have a value for the transmitted light. So the color rendering of the transmitted light is 97 for this specific solution. If I want to optimize the numbers that I have here for my glazing, let's say usually we have U value requirements that are a bit lower maybe than this. And we could say, well, I'm going to change this into a new glazing. So I turn it into argon. Then I, of course, can start to say, okay, what will I gain by doing that? And then we can immediately see that the U value is going down. I would also like to lower my summer effective G value because I think it's a bit high for what I need. Then I can do multiple things. I can start by changing, for example, the low energy coding to an extra low energy coding. This will have an effect on the summer effective G value. It will also have an effect on the U value. So here we can see from just changing the low energy coding, I got from 21 down to 16 in the G value, and the U value decreased to 1.04. And then, of course, if I want to have an even lower G value, then I can start to consider some other glazing types. Of course, I could also change into, if I had room in my existing building, I could change into a 3-layer glazing. Then I might keep my low energy coating. we can see if we just have a regular 3-layer low energy glazing, then my sum effective G value is 17. But then I can try to change it just on the first layer of glass into low extra low E coating, and then I'm down to 0.14. Of course, I can also change the second one. The glass closest to the outside is the one having the largest effect, but we do still see an effect. So now we get down to 0.12 for this solution. What you will also notice is, of course, that the U value goes down as soon as we put these extra low energy glazing on. But also, if you look at the light transmittance, with my 2-layer glasses that we started with, I had a light transmittance of the glass only on 80%. And with a 3-layer glazing with 2 extra low E coatings, I'm down to approximately 60%. And also the color rendering has changed a bit. If you want to see more details for the technical values, we can simply click this link to detailed technical datasheet. Then we will get into a whole new results section where we have much more details. So you of course have the sum effective G value that you saw on the large page, but now you can also see the G naught value for the glass alone and for the shading alone. And the G naught value is a G value perpendicular on the glazing. Usually this is what we use for both glazings and shading devices. But as with systems like lamellas or like the microshade, these are not really representative because they have a high angle dependency. So when the sun rises in the sky, the G value will get lower. And this is why we use the summer effective G value in SimShade in order to get a more accurate estimate or more accurate measure for the performance of these angle-dependent solutions. Glazings are only slightly angle-dependent, so for glazing itself, it's okay to use just the G value at perpendicular, but not for angle-dependent shading devices. Then we also have the shading coefficient. We have the U value, as we saw on the front page, and then we have details on solar transmittance, solar reflectance on the inside and outside, UV transmittance, absorption on the first layer of glass. In the luminous factors, we have light transmittance of the glass only, light transmittance of the entire system, including the shading, and light reflectance on the exterior and interior side. Then we have a color rendering of the transmitted light, and we have color rendering of the outside reflections from the glass. And then we have some manufacturing details telling about what is the weight of this glass and what is the total thickness. The manufacturing details here does not take into account the shading device. It's only the glazing that is calculated here. Unless we have in between shading, so a shading that is built into the glazing, then it will be taken into account in the manufacturing details. So now I just want to go down here in the end and show you that we have 3 different buttons here. We have a button that's called Print Report, and we have a Print Detail Report. These 2 buttons will provide you with a PDF report of the calculations that you have just done. I'm going to show you this detailed report. And the difference between the report and the detailed report is really that the detailed report is containing 2 pages, while the printed report is just containing 1 page. And the first page is the same for both of the reports. So here you can basically see an overview of what you also saw in the calculator itself. This report also contains some links. So you can see up here, we have all the blue marked text here that are linked. This is links. So if you want to, let's say that you want to, if you've calculated for microshade glazing and you want to know more about microshade reference projects, you can simply click here and it will take you to our website where we will have some references. You can also learn about the user, owner, contractor, and architectural experience. They all lead back to the website of MicroShade, where you can learn more. And then we have a link to terminology. Terminology is also found on the website of SimShade. And this is where, if there is any of these detailed or there's any of these results or input then that you're in doubt about, then you can click the terminology and you will get a document where all the different inputs and output are explained in detail. And if you cannot find what you're looking for or have questions for a certain calculation or so on, you can click the write us, and then you will write an email and we will get back to you. If we go down and look at the second page of this report, this is where you will find the monthly effective G value. So if you want to see how is this shading performing during the different months, then you can go and have a look here. So what we typically see is that we have sort of like a little bit like a smiley curve, which means that we usually have a higher G value during the winter time than during the summer months. And the reason for that is the position of the sun in the sky. During the summer months, the sun is high in the sky, and for a lamella system that we have calculated here, it also provides a lower G value during the summer than it does during the winter. And then you might ask, why do we have such a peak here? Why isn't it flat? And there can be several reasons for that. If you, now I calculated for Denmark, but let's say that you have calculated for a really southern location, then it could be because the sun is so high in the sky that there's not that much solar radiation on the facade. And we set a threshold, in this case, on 150 watt per square meter, which means that we might not have 150 watt per square meter because the angle between the sun and the window is so high. Another reason could be that if it's a lot of overcast sky during June, then again the solar radiation might not get up to 150 watt per square meters, and the shading won't be activated as much as it is in April, May, and June, July, August. In this second page, you also have tables with the angle-dependent values on G values, solar transmittance, light transmittance, solar reflectance, light reflectance, and absorptions. And these values are given so that if you have another building simulation program where you need to calculate a certain shading device and you need the angle-dependent values, we give you the angle-dependent values here, so you can simply go and import them into the calculation tool that you're using. It might also be interesting just to learn to know how is this angle-dependent shading devices actually performing. So let me go back to SimShade. So now I have shown you the detailed report, and I will get back to the page where we started because we still have some outputs here that I haven't explained. So we also have here economics, and here you can see the price of the glass, an additional price of this external lamella solution that we chose. And because this is a dynamic control shading, we also have some costs for the electrical installation, BMS programming, cost of project planning, and cost of the building site, service and maintenance. And we have a lifetime expectancy. And this should all sum up to a total cost of ownership. So if we want to see more details, we can go into the detailed economic calculator. And here we can see all the numbers in detail. The first section here is a cost of a microshade glazing. So whatever glazing you have calculated or solution you have calculated, you'll always find it down here. If you have already calculated a microshade glazing, we will find an alternative solution that we will compare with. You will see that we have these boxes around some of the numbers. And this is because that you can actually go in and change your number. So let's say that You have an external lamella solution. It does not cost 290 euros per square meter. Your price is 250. Then you simply go and type it in, and then the total cost of ownership numbers will change, and so will the savings for what you can gain by using a microshade glazing. We also have a short list of the key features of the microshade solution that you have chosen, and also the key features of this external lamella solution. And it's of course also possible to print a report for these economic details. I'm not going to do that right now. I think we should go back to the overview again. So now I want to show you, first of all, I'll just try to do a calculation, just to use the same glazing as we had with the lamella system, but I'm just going to do a calculation for microshade glazing. And then I want to show you down here under the input section, we have a list of the calculations that we have done. The last 5 calculations will show up, and there's some boxes here that you can tick off. So if I just tick off the last 2 boxes, then you will see that suddenly this compare button become active. In order to compare 2 solutions to each other, they need to share the same location, window angle, and orientation. But let's try to see if we compare these 2 solutions. First, we have the shared location, window angle, and orientation. And then we have each of the glazing and shading built up for our solution. And then we can see the results that we saw on the first page. We can see the overview. So we have the technical specifications, we have a cost of the glazing, and we can see that for both solutions next to each other so that they're very easy to compare. So you can see for the microshade glazing here, we have far less lines in the economics part because microshade don't need any electrical installation. It don't need extra time at the building site. And the maintenance that we have here is basically window cleaning because it's sheltered in between the glass. So there is no maintenance other than cleaning the glazing. If we want to see more of the details, we can simply again click here, detailed technical data sheet, and then we can go and have a look. So if we just look here, we can see the summer effective D value of the 2 systems. In this case, we had the lamellas that were tilted at 45 degrees, and we had extra low energy glaze, extra low E as the 2 coatings. If I really want to compare, I should actually change this to low E, because then it would be the same for the microshade glazing. So I simply change it, and then I press calculate again, and then we can see the number here. So if you go and see the numbers, we can see that the summer effective G value is basically the same for the microshade glazing and for the lamella solution. If we look at the light transmittance, go all the way down here, we can see that the light transmittance of the system when the shading is down is 23, while it's 73 for the glass itself. And the light transmittance for the microshade, this 3-layer glazing, is 51. So it means that when the shading is activated, the microshade will provide more light than we see with the external lamella system. If we then And now I want to go back again to the overview of the shading report. What I'm going to do now is that I'm just going to do, it forgot what I had done. So I'm just going to do a calculation for the microshade glazing again, because I want to show you just some last details. If you have calculated with the microshade glazing, you can get what we call a tender text. So if you saw it before, this link was not active, but now because I calculated the microshade glazing, it becomes active. And the tender text is simply a document describing the technical values of a microshade glazing. So you can see here that we have a G60 value, which means the G value at 60 degrees solar height. We have a G15 value, so the G value at 15 degrees solar height, and so on. So if you have a project where you anticipate to use microshade, you can go and do a calculation for your specific glazing buildup and then get the tender text. And please note that if you have multiple glazing buildup in your project, you need to calculate the tender text for each glazing buildup, as these values will change depending on the glazing buildup. And then I would just say that all the different calculations that we have been doing here, you can, all the different pages that I have shown you here in SimShade, you can get a report on every one of them. And the report is simply intended to be used to share with your collaboration partners on a specific project, because it contains all the technical data. You can actually choose here in this one if you want to include the economic section or not. If you tick this one off, you only get the technical values and no prices, but you can also include the prices if you want to. And then, as you saw in the reports, we had this list of all these links. We also have them here in SimShade. So if you need to know specific, if you forget, okay, what is this summer effective D value all about? You can read what is the summer effective D value, or if you are in doubt of any other inputs or outputs, you can check it out here. And then I would say that if you have any questions regarding the calculations, something that you are not sure what to do about, then you can of course always use the write us button and write us an email.